Good day, ladies and gentlemen. This discussion or this presentation is talking about cost saving on cyclones. Cyclones are, for those who may not know, a basic piece of equipment that separates particles on size or on density. But we do get the request from our clients on how can we reduce the operating cost or the production cost on the cyclones. And what they have in mind is a cheaper or less expensive part that they can be used. So when we tell them that we may have a solution, but it's more expensive, they tend to become disgruntled and they feel that we haven't listened to what they were asking. So in this presentation, we're going to look at some of the case studies where we were able to help our clients and also some ideas that can help our clients with saving cost and improving productivity. The case studies I'll be covering relates to reduction in labor cost, improvement in maintenance, space reduction on dense media, classification applications, brief look at where we could help our client with a sensor, and then closing down in terms of some comments on training. In this application, in terms of the reduction of labor costs, it's a pre-concentrating dense media separation process, feeding then a mill section. This cyclones originally were cast iron, expected life about 1.5 months. And the client requested to see, can we improve on the operational life of the unit? So we suggested that we rotate the parts during every maintenance, 90 degrees, and that extended the life up to 2.5 months. During the initial stages of this process, or the operation, it was found that there was relative frequent blockages at the inlets of the cyclone. And the reason for that being was that the crusher settings had to be increased in order to increase the throughput through the process plant. So at the end or just before the maintenance period, it was then noticed that these blockages started to diminish, and the decision was made to take one of the worn units, cut the inlet open, get the dimensions, and a new cyclone was supplied for this process. Ceramic line cyclone, because to make modifications to a casting is not that economical, quite expensive. And by converting to the ceramic line cyclones, the operational life increased to 3 months without the need to rotate parts. And that helped the client with the cost saving in terms of reduction of labor. He doesn't have to every time get people in to help to loosen the bolts and rotate the parts and put them back together. The client then asked if we could continue looking at improving the life. So we started to look at silicon carbide. We had to make some design changes to improve the life of the unit, and we end up now with a unit that's completely silicon carbide, and the operational life is now extended to 9 months. All indications are it's possible to extend it further. So the cost saving at this point between a silicon carbide unit and the cast iron original cyclones is about 1.4 million rand per annum, or about $99,000 US. Compared to this ceramic line option, 640,000 per annum, or about $44,000 US. Now it's not big money, but, and this is important to remember, this cyclone sits before a milling circuit. And what the client has noticed just before maintenance had to be commenced was that the yield, the amount of mass going through the spigot of the cyclone towards the mill became too much. And they had to cut back on feed to the plant. By having now the cyclone operating with more consistent operating parameters, it's now streamlining the throughput through the plant as well. And there's additional cost saving. The next item, in terms of maintenance, cyclone clusters is sometimes, that's a cyclone cluster there. is sometimes installed in positions where it's not always easy to get access to lifting requirements, or there's competition against other equipment during maintenance. It becomes a bit more labor intensive in those type of situations. And then the maintenance is sometimes neglected. And when you neglect the maintenance, then the cyclone efficiency starts to become affected, and that spills over then into the rest of the process. So one of the ideas that we came up with is to incorporate a jib crane into a cyclone cluster. So each cyclone cluster has got its dedicated lifting mechanism. You save cost, you don't have to, you save labor, it's more safe to do the maintenance. So there is no, and there's also no competition. You can do the maintenance, or you can do maintenance whenever you need now to do it. Because you can now do maintenance on a more frequent basis, you're now enhancing the efficiency of this unit or this cluster, and thereby also helping with the efficiency of the overall process. Moving on to the space reduction case studies. In dense media separation, cast iron is quite a commonly used material of construction. Our cast iron cyclones is quite popular in the industry, but it is sometimes possible to misalign the parts. The picture that you see now, the green part is the spigot, the red part is the cone, and there is a misalignment between these two items. This misalignment can now cause production losses because it's misplacing, it's creating an inward step. So it's misplacing material in the wrong direction. But it's also creating aggressive turbulence. And this turbulence now shortens then the life expectancy of the parts. The picture that you see on the right are the items from this plant. And you can see the localized wear. The units have to be replaced while the rest of the spigot is actually still in good condition. So we embarked on a project to relook at our cast iron cyclones, and one of the design changes that we've made is to look at the self-locating ring. Now you can locate the spigot and the cone together without the risk of getting an inward step, unless you do it deliberately. So that's already now helping to enhance the efficiency of this unit over a longer period of time. Another aspect that we've noticed was that you tend to sometimes in certain applications get a localized wear between the joint between the cone and the spigot. And that resulted in us looking at making a one-piece unit called the monocone. Now this monocone is quite suitable for low yield applications, and low yield, I mean, there's a small amount of tons that's going through the spigot. And the reason for that being, if you have a high yield application, then your spigot starts to wear too quickly compared to the rest of that unit. And then you have to replace the spigot, now you have to replace the whole unit. So that is not really cost effective. But in applications where you have a low yield application, like in the diamond industry, that will be successful. For your high yield applications, silicon carbide is again an application that's proved to be quite successful for us. The cost saving on this specific item, on this specific plant, is about 30,000 Rand per annum. So again, it's relative small money, but the impact, because the cyclone is now operating more consistently, because the spigot diameter is a very important parameter for good dense media cyclone performance. That is now additional cost to keep savings to keep in mind. In terms of classification, this is a milling cyclone operating in a SAG ball mill circuit. The material is quite aggressive, as seen by the picture in the center. And originally, these cyclones were supplied with polyurethane spigots, and they lasted only 5 days. So the client decided to move over to rubber spigots, and that only lasted 7 days. So the client decided, no, rather go back to the polyurethane spigots. But now, because of this continuous use of polyurethane spigots, he sometimes ran out of stock, and then he was operating these cyclones without a spigot. Now, to operate a cyclone without a spigot in a milling circuit is also looking for trouble, because you're placing the whole milling process now under strain. So the spigots that this specific cyclone is using, as shown in this picture on the left-hand side, the item on the left-hand. That's the polyurethane spigot that was used. The item on the right hand shows a ceramic lining that is encapsulated in polyurethane. And based on the success with silicon carbide, I decided to look at silicon carbide as an option for this specific client. He took the unit, installed the unit, and I asked to come and inspect the unit a couple of days later. So that's the unit that I had to inspect. And I was looking at this unit and I've asked him, what am I looking at? Because at this stage, it looks like the polyurethane spigot. And he told me, no, that is your idea of the silicon carbide. It only lasted 4 days. So you never too old to learn. The reason why it only lasted 4 days is silicon carbide is very hard, but it's also very brittle. And the type of material being processed through this milling circuit indicated that this material is not the right material of construction. During that period, we were also looking at redesigning or additional design to our spigot range. And this design allowed us to re-look at a rubber spigot. And that spigot that you see on the picture on the right bottom end is after 19 days what the unit looks like. So the client is very happy with this current situation, and we are looking at improving it further. So again, the cost saving between polyurethane and rubber is about 110,000 Rand per annum, or about 7,500 US dollars. But the additional saving in terms of optimizing the mill, that's where additional cost saving is coming into the equation. Then moving on to the advanced prototype. Underground coal mines uses continuous miners, and they've got rotating drums, and on those drums are peaks. The picture that you see on the left-hand side is a statue that the plant personnel constructed of those peaks that came loose from that continuous miners or broke off. They find their way to the operating plant. You've got overbelt magnets, but due to the weight and the design of this unit, it's not always possible to have 100% success rate in recovery. The point of this peak is tungsten carbide. Very hard and can create a lot of damage inside the plant. Now, in coal operations, ceramic line cyclones are used extensively because it's cost effective. Unfortunately, when these peaks get into the ceramic line cyclone, it creates havoc. It impacts on the tiles, destroys the tile, and eventually you get the exposed shell. Now, the plant operational people don't know about it until the steel has worn ultra thin and the cyclone burst open. Now you are forced to have a shut. Now, one of the solutions to this type of scenario of foreign metal is the use of cast iron, and it can be done in different alloys. Very successful if you have foreign metal. However, if you have not a high frequency of steel, then ceramic lining tend to outlast cast iron units. And in this event, or this case, the client preferred to stay with ceramic lined cyclones. So we asked, what can we do to help him with this steel or foreign metal problem? And what we came up with was a sensor that would then be fitted onto the cyclone and be able to detect the presence of steel. Now, graph that you see at the bottom end, the purple and the burgundy, or the dark red line, indicates where steel has entered now into this unit. This information has now also helped the client to generate the databases to say, how often do you have these steel events? Now, here's the interesting thing. When we started with this sensor, we said, we need now to look at ways of shutting down the cyclone so that the steel can leave the cyclone, because we want to protect the unit. As more information became available, we realized that idea is not the best idea. And the reason for this is as follows. 1,000 ton an hour coal plant, processing, having a yield of about 60%. And your current coal price, $100 per ton, and we work at 14.5 Rand to the dollar, is generating revenue in the region of 870,000 Rand per hour. To put it more in perspective, 240 Rand per second. If you want to go to dollars, $60,000 per hour, or $16.5 per second. So this has now turned into a different approach where the sensor is used as an advanced warning to the client, because you don't see the steel coming into the plant. And they don't know what damage has been caused. Now that with the sensor, you know which items have been exposed to the steel. And with the next maintenance, you can inspect those units more intensely and make sure that you are not caught off guard by having unplanned shuts, because those ones are not short and you're losing a lot of money. Then lastly, in terms of training, Multotec provide training in our head office, obviously adhering to social distancing. It's also moved onto an online platform. It can be on-site specific sessions as well as online sessions, and then there is access to the YouTube knowledge platform and the Multotec website. Now, the importance of this training is that it is not sales presentations. It is to share information and help our customers understand why a specific piece of kit, of equipment has been designed like this. Why is it in that position in the plant? What is the impact if that piece of equipment is not operating correctly? And that comes into the maintenance, how to do maintenance correctly, how to ensure that you use the right items. Because if you're looking at saving cost by using substandard parts on the equipment, eventually it's going to bite you. And these training sessions is putting the bigger picture to our clients, giving them a better idea of why we are so fanatic in terms of ensuring that the equipment are being maintained with the correct OEM parts. Sometimes people say, oh, but I know this, it's obvious. Yes, and that's part of our aim, because a lot of the times our clients already know this, but they've forgotten about it. And these training sessions are then taking this piece of the puzzle, building the complete picture, and just helping our clients to understand again the importance of proper maintenance, and also then understand how the equipment, if not operating correctly, what financial impact it will have, because not everyone understands that there's a financial implication if the equipment is not operating correctly. I trust that this presentation will be of use to you. There's something you can take from that, and I thank you for your time.